All right, Matthew, here we go. We've got lesson 5.2.3 more completing the square. We're going to dig a little bit deeper into completing the square here. So we got 5-83 says solve each of the following by completing the square. Remember when we're completing the square, we want to start by isolating the x squared and the x term. So here's my x squared and x term. It's not isolated. So I'm going to start by subtracting 7 from both sides. So subtract 7 from both sides. I get x squared minus 6x. I'm going to leave a blank right here. We're going to see why in a second. I'm going to leave a blank right here. Okay, our next step in completing the square is to find out which number will complete the square over here on this side. And then we add that number to both sides. And our rule for that was we saw when we had perfect squares, that the perfect square number was always half the middle term and the square of the last term. So I'm going to take half of this. So I do negative 6 divided by 2. And then I square it to find my other term over here. So negative 6 divided by 2 is negative 3 squared. So this is 9. So 9 is the number that I'm going to add to both sides. Now that I've added that number to both sides, my next step is to clean it up a little bit. We just created a perfect square, right? So what multiplies to give us 9 but adds to give us negative 6? It's negative 3 and negative 3. That's this number right here that we squared. So this would be x minus 3 squared. We always know whatever number we square here is this term right here. Remember, we saw this pattern here. This number is twice this. This number is this number squared. On the other side, we end up with 2. At this point, we're going to solve by taking the square root from both sides. And we get x minus 3 equals, anytime we take the square root, we have to realize there is a positive and negative possibility. So we do plus or minus the square root of 2. Root 2 does not reduce. We're almost there. Our last step that we need to do is add 3 to both sides. Remember, when you do this, we're going to leave the 3 in front of the plus or minus sign. So we get x equals 3 plus or minus the square root of 2. Square root of 2 is something like, I don't know, like 2.3-ish or 2.4-ish. So this just means 3 plus that, like 2.3, and then 3 minus that. So there's 2 answers there. Next one, we isolate first. We get p squared plus 2p. I'm going to leave a blank here, minus 1 blank there. Okay, we got to find out what number completes the square. So I'm going to take 2, cut it in half, and square it. So if I take 2 and cut it in half, I get 1. And 1 squared is still 1. So the number that I'm going to add to both sides is 1. So what perfect square did I just make? Well, the number that I squared was 1 over here. So this is going to be p plus 1 squared. Again, we can see the pattern here. This number is double this. This number is, this binomial part is squared. On the other side, we get 0. Negative 1 plus 1. Okay, now we take the square root from both sides, and we end up with p plus 1 is equal to plus or minus. Square root of 0 is just 0. Finish it off by subtracting 1 from both sides, and we get p is equal to negative 1 plus or minus 0. Well, negative 1 plus 0 and negative 1 minus 0 are the same answer, so we only have one answer for this one. We've got p is equal to negative 1. This just means that if we were graphing this quadratic equation, or as if it was written as a quadratic function, we would only have one y-intercept. So we'd cross the axis at just one point. Last one on this group, we're going to start by subtracting 9. We get k squared minus 4k. I'm going to leave a blank right here. Negative 9, leave a blank right there. We got to find the number that completes the square, so I take half of the negative 4 and square it. So this is negative 2 squared, which is positive 4. So 4 is the number that I add to both sides to complete the square. Remember, if you add it to one side, you have to add the other side to balance the equation out. Okay, the perfect square that I just made. What number did I square up here? I squared negative 2, so this is x minus 2 squared. On the other side of the equation, I get negative 5. I'm going to take the square root from both sides, and I get x minus 2 equals plus or minus the square root of negative 5. Add 2 to both sides. And I get 2 plus or minus the square root of negative 5. Now, this one doesn't make a lot of sense. There are no numbers that if you multiply them by themselves gives you negative 5. So we're not allowed to have negative roots. So we would say that there's no real solution. Now, in a couple lessons, we're going to find out what the imaginary solutions are. But for right now, this doesn't make sense. This doesn't work. Basically, what this means is if we were graphing, we would have a parabola that looks like this, where it doesn't cross the x-axis. That's why we're not getting solutions here. All right. All right, so this one, they've already isolated the x squared and the 5x. So now I have to find out what number I'm going to add to both sides. So I take the 5, divide by 2, and square it. This is a little bit tricky because 5 isn't divisible by 2. We're just going to call that 2.5. And 2.5 times 2.5, if you didn't know, is 6.25. So 6.25 is the number that we add to both sides of the equation. So I got x squared plus 5x. And then in this blank right here, and in this blank right here, I add the 6.25. We clean it up at this point. The perfect square that I just made, the number that I squared was 2.5. So this is x plus 2.5 squared. Negative 2 plus 6.25 is 4.25. This point, we can take the square root from both sides. Remember, when we take the square root from both sides, we have to include plus or minus to show that we could have a positive answer or a negative answer. 4.25 is not a perfect square. So at this point, I can just subtract 2.5 from both sides. And I get x is equal to negative 2.5 plus or minus the square root of 4.25. All right, last 4. If you want to try this out on your own to see if you're getting the basic steps right, go ahead and just pause the video right now, and then you can check to see if you get them right. So I'll give you a second to pause, and then I'll just solve these really quickly. All right, here we go. So if you haven't paused, you can just watch me. I'm going to subtract 52 from both sides. That gives me w squared plus 28w. I'm going to plug in a number here, negative 52, and I'm going to add the number to both sides. So I'm going to take 28, cut it in half, and square it. So that's 14 squared, which is 196. So 196 is the number that I add to both sides, 196. All right, so this perfect square over here, remember the number that I squared was 14. So this is w plus 14 squared equals 196 minus 52, that's 144. I take the square root of both sides. And I get w plus 14 equals plus or minus 12, because the square root of 144, that's a perfect square, is 12. I am now going to subtract 14 from both sides. Use my subtraction property of equality. And I get negative 14 plus or minus 12. Since both of these are integer values, I can actually write down the two solutions for this one. So one of my solutions is negative 14 plus 12. That's negative 2. My other solution is negative 14 minus 12. That's negative 26. There's my two answers. Now, if you would have factored this and then solved using the principle of zero products, you'd see that you get the same answer. That might have been a faster way to do this one. Next one, we subtract 4 from both sides. And we get x squared plus 5x. We're going to add a number to both sides. Okay, so we're going to take 5, cut it in half, and square it. So we take this number, cut it in half, square it. So this is 2.5 squared, which is 6.25. So we're going to add 6.25 to both sides. And we end up with, this is the perfect square of 2.5. And over here, we get 2.25. Take the square root from both sides. And we get x plus 2.5 is plus or minus. This is actually a perfect square. 1.5 times 1.5 is 2.25. So this is 1.5. And now we're going to subtract 2.5 from both sides. And we get x equals negative 2.5 plus or minus 1.5. Since there's no radicals, we can write down our two answers. Negative 2.5 plus 1.5 is negative 1. Negative 2.5 minus 1.5 is negative 4. Again, if you would have factored this one, what multiplies give you 4 but adds to give you 5. So that would have factored into x plus 4, x plus 1. You would have got these two answers. All right, this one. I just need to find out what number to add to both sides. So I take the 16 and cut it in half and square it. So this is negative 8 squared, which is 64. So 64 is the number that I'm adding to both sides to make a perfect square binomial over there. So the number that I squared here was negative 8. So this is k minus 8 squared. On this side, 17 plus 64 is 81. So I take the square root of both sides. I get k minus 8 equals plus or minus a square root of 81 is a perfect square, so I get 9. And now I add 8 to both sides. And I get k equals 8 plus or minus 9. Okay, so no radicals there, so I can write down the two answers. K can be 8 plus 9, that's 17. But k can also be 8 minus 9, that's negative 1. There's my two answers. Last one. Let's start by subtracting 129 from both sides. So I get x squared minus 24x. I'm going to put a blank there because I'm going to add a number to both sides. Oops, 129. Okay, so to find out which number I add to both sides, I take half of this number, so negative 24, cut it in half, and square it. So negative 24 cut in half is negative 12, and negative 12 squared is 144. So 144 is the number that I add to both sides. Now remember, we're always going to add a number to both sides. We're never going to subtract, because when we square it, no matter what, it's going to be positive over here. All right, so on this side of the equation, I've got x minus 12, because negative 12 is the number I squared. On this side, let's see, 144 minus 129, I think that's 15. Now I take the square root from both sides, and I get x minus 12 equals plus or minus. Square root of 15 is not a perfect square, and it doesn't reduce because it's just 3 times 5. So I'm just going to leave that as the square root of 15. Last step, I'm going to add 12 to both sides. And I end up with x is equal to 12 plus or minus the square root of 15. And that's just how we're going to leave that answer because we've got that irrational number here that it just goes on forever and I can't write it down. But we do know there's two answers there, 12 plus the square root of 15 and 12 minus the square root of 15. All right, that's all I got. Math hard. See you later. Bye.